9.2, the binomial theorem. So this is just a way to make your life easier, really. The questions that are on the exam, let's say we had not done this section, you could still figure out. It will just take you much longer to do it. So basically, we're looking at binomials, and we're going to observe some patterns. Have you ever seen Pascal's triangle before? It's a triangle with a lot of numbers in it. Okay, so Pascal's triangle looks something like this.
Perhaps I have seen it.
And it goes, so on and so forth, all the way down. So basically what we've got is, if we take the numbers above and we add them together, we get the next number. So ones are always down the sides, no matter what it is. So then to get this number here, we do 1 plus 1 is 2. To get this one over here, 1 plus 2 is 3. 2 plus 1 is 3. And then this would be like 1 plus 0, which is why they just get the ones on the outside. So then over here, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Down here, 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and so on and so forth. And so we could keep going if we wanted to. With the next one, it would be 1, 6, 15, 20, 15, 6, 1, going across. So knowing this pattern will make your life much easier in terms of solving out binomials raised to a power. And that's really what we're going to be using it for. And so if you wanted to see what it looks like in that method, still using Pascal's triangle, I'll show you what it looks like with like an A plus B raised to a power expanded out as well. Do y'all have all this so I can slide it? Okay. So if I gave you A plus B raised to the n, and we're going to do it for n is equal to 1 through 5, or well, I guess 0 through 5 technically. That'll match the triangle that we have up here. So if you have room and want to do it beside it, you can. But it's going to take up a decent amount of space, so you might not want to do that. So A plus B to the 0. Anything raised to the 0 is 1. A plus B raised to the 1 would be following the pattern that we had up there. 1a to the first, b to the 0, plus 1a to the 0, b to the 1. Then if we had a plus b squared, we would have 1a squared b 0 plus 2a 1 b 1 plus 1 a 0 b squared. So notice I've got 1, 1, 1, 1, 2, 1. Then keep going. A plus b cubed. So I've got 1 a cubed b 0 plus 3 a squared b 1 plus 3 a b squared plus 1 a 0 b cubed. So this one is 1, 3, 3, 1. And this would have been in Algebra 2 where we got that pattern from when we had a plus b cubed or whatever, 2x plus y cubed or whatever. This would have been where that pattern came from when we did those problems. I say that because we just did that in Algebra 2, and I think I need to show them this pattern because I think they were confused about where that came from. But anyways, a plus b to the fourth, we would have 1, a to the fourth, b 0, plus 4, a cubed, b to the first, plus 6, a squared, b squared, plus 4, a to the first, b cubed, plus 1, a to the 0, b to the fourth. And then the last one to match our triangle that we had, a plus b to the fifth, 1, a to the fifth, b to the 0, plus 5, a to the fourth, b to the 1, plus 10, a cubed, b squared, plus 10, a squared, b cubed, plus 5, a to the first, b to the fourth, plus 1, a to the 0, b to the fifth. So aside from the Pascal's triangle pieces here, just underlining them so you can see them, and we could keep going if we were so inclined. But aside from those pieces, what else do you notice about each of these going across? In terms of my exponents. So alphabetically, now obviously it's not always alphabetical, but for the sake of this, the A terms are in descending order, the B terms are in ascending order, okay? And notice it increases or decreases by 1 every time going across. So that's how we would get that pattern to the point where we could keep going and go all the way down to like a plus b to the 10th if we wanted to. We could keep going. Now it's going to have an obnoxiously large amount of terms, but we can do that. Okay? And just knowing simply what happens at each term can help you as well. So the way some of these questions are going to look is they're going to say, they'll give you something like x plus y to the 7th. What is the fourth term? Okay, so if they asked us what the fourth term of a plus b to the 5th is, we go 1, 2, 3, 4, and it might ask you what the leading coefficient is of it, and you would say 10. Now, obviously, if this was something like with numbers, then it's a little different, but that's how we can find that using this Pascal's triangle / the binomial theorem.
So how do we get, like, the numbers as part of the Pascal? Like, I'm just confused where the 10 came from, I guess.
So still this up here, so it would be the 6 plus 4 produces a 10. 4 plus 1 produces a 5. So like if I wanted to keep going with this, this would be still 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And then just a 1 to end it. And it's always going to follow some sort of a pattern. So like the odd ones, the middle term, it like everything on the left matches the stuff on the right. The even terms, it's like you could fold it in half, like symmetry, and it matches. So that can also kind of help you when you're doing your stuff like that, knowing if it's even or odd to keep going. And if you wanted, 1 plus 6 is 7, 6 plus 15 is 21, 15 plus 20 is 35, 20 plus 15 is 35, 15 plus 6 is 21, 6 plus 1 is 7, and then just 1 on the end. So that would take us out to 6, 7, and that would be how we just keep going with it. But that's kind of where this stuff comes in. Now, you could multiply a plus b to the 5th out by foiling constantly, but that's going to take you a lot longer then more than likely doing this triangle thing. You know, if you know, like, say you remember out what the fifth row is, you don't have to write out the whole triangle every time. You could write out the fifth row and then just keep going for the ones that you needed to know, kind of thing. Like knowing the pattern 1, 5, 10, 10, 5, 1, and then keep going from there. So, but I would definitely make sure you understand the process of the triangle and how it works, because that will be kind of your clue in to make your life easier on that part of the exam.
So would it be true to say that the number of terms is n plus 1?
Yes, I think so. Yeah. Because, like, this one would have been 0, and that would be 1. This would have been 1, so that would be 2. So, yeah.
That's convenient.
Okay. So binomial coefficients. I need a different color here. So the binomial coefficient, and I'm not sure that you actually need all of this stuff out of this section, but we're going to go ahead and do it as if we do need it all. Because in the AP book, all I really see is it asking you questions about this stuff, but some of this other stuff is just beneficial to know, so why not? So the binomial coefficients that appear in the expansion of a plus b to the n are the values of NCR. So Josh, you've seen this before, NCR.
Yeah.
For R is equal to 0, 1, 2, etc., all the way out to n. A classical notation for NCR, especially, I can't spell, in context of binomial coefficients, is, and they write it like this in parentheses, n over r, and these are both read as n choose r. So I have n things taken r times, like r at a time or whatever is how we would think about that. We can actually use our calculator to do this, or under, it's math, and then it's probability. How do they write it? Math. It'll be listed as PRB at the top, like that, and then it's option number 3, which is NCR. Now, when it comes up, that you'll have to have a number typed before that, before the n value. So, like, if we did, let's see. That was the wrong button. Where's the button I'm looking for? is. Okay, so you're gonna look. So type the number 5, and then you'll push the NCR button like that on your calculator, and then you're looking for the little curly cube bracket, which is the second of the parentheses, and then you'll type in 0, 1, 2, 3, 4, 5, and then close off the brackets. So it'll look like this. So 5, math, probability, option 3. Then you'll hit second, the parentheses, which brings you the little curly bracket. 0, the comma, which is the button I was trying to find and I couldn't find. The comma is right here by x squared.
Do you have any of the bigger graphs? Because one of my graphs is going out farther than 5. It's probably not supposed to. But
I don't think it's. Maybe it does. I can see.
Okay. I was like, I have some extra ones that I haven't used in my folder.
Let me see if this is. Like this one?
Yes.
Thank you.
I just made each thing equal to like 2.
Oh, okay. That's why I looked at yours and then I looked at Virginia's and I was like,
Uh-oh.
I was like, wait a minute.
Yeah, I think I wrote a note that
I probably
Did
messed
that.
something up.
probably.
Alright, so when you're done typing it in, it'll look like that. And then you hit enter and notice it produces 1, 5, 10, 10, 5, 1, which is exactly what we got from Pascal's triangle.
So my calculator is doing a little different thing. So I put in 5, and I go to the NCR thing, and it puts the 5 in the N spot.
Well, that's what's happening. The newer calculators are going to do it that way.
So
Mine
that's-
doesn't let me put it on the N instead. So yours is saying like 5C and the little bracket thingy.
5C blank.
Well, yeah, you have to type all that in.
So I type that into the R spot.
My calculator just doesn't allow me to replace N and R. You just have to put it before and after.
This one doesn't either.
So
I still haven't
how far
charged
out are we
it.
going to?
Just through 5.
Okay, so do I write that how my calculator shows it?
Yeah, that's fine.
Okay.
I would know what it means. I just did it this way because this is how my calculator does it. But yes, if yours does it the other way, that's fine. And so this will produce for you 1, 5, 10, 10. I guess they don't have commas in there. 5, 1. So if this was on the calculator portion and it asks you for it, you could do it out this way. Like if it went out to, let's say 9. So I don't have to type everything in again. If you hit second enter, you can avoid typing everything in again. So I'm going to say 9. And then 6, 7, 8, 9. And do it that way. It's going to produce that at 9. So if it was 9 NCR, and I'm just going to 0, ... 9. Then it would produce for you that you get 1, 9, 36, 84, 126, and then it repeats. So then 126, 84, 36, 9, 1 would be what that produces. So then you could say the leading coefficient of the fifth term, 1, 2, 3, 4, 5, is 126.
I think I just noticed that, well, maybe. Okay, yeah, okay. The odd ones all have numbers that you can like divide them by n. But the even ones are kind of not like that. They're a little silly.
All right, the actual binomial theorem then. The actual binomial theorem says for any positive integer n, a plus b raised to the n is equal to n over 0. It's not over, but anyways, in parentheses, n and 0. A to the n plus n1 a to the n minus 1b plus dot 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 plus n r a to the n minus r b to the r plus dot 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 plus n b to the n where this is just another way to write what we already did basically, where nr is equal to ncr is equal to n factorial over r factorial times n minus r factorial. So this is the part that I'm not necessarily sure that you particularly need this for the exam, but it's all in this section, so we'll just go ahead and do it. We might watch the video that goes with this stuff. Wait, was there a video for this? There wasn't a video for this, I don't think. Not like this specifically, so I don't know. Anyways, sequences and series, there's videos that go with them, so we might do that. But, did you finish it? So, do y'all know what factorial means?
Yeah.
Or what that causes us to do?
Yeah, I like factorial. It's kind of fun.
So factorial, so like if I had 5 factorial, that would say that's 5 times 4 times 3 times 2 times 1. So it's add up or multiply everything that number in before it. So that's why like on the clock up there at 3 factorial, which is at 6 o'clock, it's 3 times 2 times 1, so 3 times 2 times 1 is 6. And that's why it's like that on the clock.
I saw this thing that said that factorial is kind of like how many ways you can organize like n number of objects.
Total, yeah.
Yeah, and that's why 0 factorial is 1, because there's only one way you can organize 0 things.
So this formula would just help you in expanding it as another method other than just using the Pascal's triangle thing, basically. We don't need the rest of the stuff with this, but we'll look at some examples and a few of the multiple choice questions tomorrow, because like one of the multiple choice questions says the sum of the coefficients of 3x minus 2y to the 10th is, and then you have to figure that out. And so we can go through and like figure out what that would be for, each given thing or whatever. Because that's kind of what, from what I can see, the way that they ask their questions and why this is relevant to the AP stuff there. So